Okay, we'll carry on with application of reactivity series and the displacement reaction. I said more reactive will displace less from its compound. Now this is a famous application of it. From centuries it is used. Iron oxide, Fe2O3. It is a compound of which metal? Iron. In powdered form, it is mixed with aluminum powdered. Now look at the position. Aluminum is quite high, iron is below. When these two metals are heated together, given a spark, the activation energy using magnesium. When magnesium react, produce lots of energy. You need a spark like that. And that spark basically start this chemical reaction. More reactive aluminum is there to displace less reactive from its solution. Aluminum will pour electron and iron will accept electron back. And accepting electron back, iron is sent packing. But this displacement reaction is of a type, all displacement reactions are exothermic, but it is huge. Huge amount of energy is released and delta H for this reaction is very negative and temperature that is produced is above 3000. So many metals are molten at 3000, rather most metals are. And then a very high temperature that is created basically sends iron to liquid form. As a result, what happens that if a railway track is cracked from here, the molten iron that is produced, it flows in between the crack and a molder will set it. So the railway track is welded or any iron bar is welded, used for construction and other purposes. Aluminum oxide to make a top layer. So that will even prevent further from any kind of rusting. So huge application, displacement reaction, more reactive as displaced, less reactive, and the process release so much of the heat that it is used for welding even from centuries and nowadays. Okay. Another, sometimes some metals are extracted by this way, like titanium, very rare metal. If titanium chloride normally is present, it is heated with magnesium. Magnesium being more reactive, might is right, more reactive, less reactive is displaced out. So magnesium chloride is formed and titanium is obtained in the original form. It means we have extracted a metal from its compound, the titanium, used a space age metal used for jet aircraft wings and also as a jewelry. Another application, notice this is copper oxide. The copper metal is even below hydrogen in the reactivity series. And if you heat this black copper oxide, black powder it is, with hydrogen gas, a very common question in MCQs and other stuff, copper oxide black heated with hydrogen gas, we'll find out reddish pink copper separating out and hydrogen gas has turned to H2O. Okay, and the gas steamy fumes are seen here, and if these steamy fumes are provided a cold atmosphere like placed around, surrounding is of ice, you'll find out the condensed and a colorless liquid is formed. And you want to test the colorless liquid, add anhydrous copper sulfate, and it will turn from colorless to blue, confirming that steam is produced, confirming that water is produced. So sometimes they ask the identity of colorless liquid, that is water, you test with a chemical test. Okay, so this is basically extraction of copper from its ore, which is copper oxide, extraction of titanium from its ore, which is titanium. Okay, this can be called as extraction of iron, but of course this is not a feasible process. Iron is extracted by a very cheaper process, we'll see, by reacting with carbon monoxide. Here this process is used for welding basically. Okay, so displacement reaction based on the fact of more reactive displacing the less reactive has its applications. Okay, and the most important application of course is thermite reaction and the extraction of metals from their ores. Mark.